Hello, I'm Walter Casado. I'm a senior controls engineer here at Cates Control Systems. I'd like to welcome you to webinar number 3 in our validation system series. In our first 2 webinars, we built a case for having a validation system to reduce unloading errors. We also showed how costly these errors could become if they moved downstream into the process area, warehouse, or even all the way to the customer. In today's webinar, we'll look at how all the pieces fit together in the system we're building, which is called TransferMinder. I'm going to turn off the camera now so we can focus on the presentation. Okay, please keep in mind as we're discussing this, we're still in the development stage. So what you're going to see is not a finished product. So there are rough edges and holes, but we have enough to show the basic idea. As we talked about in webinar number 2, it is especially important to us to make sure a new system is welcomed by the operators and not dreaded, so that they have to be smooth, easy to use, and make sense as far as a new system is concerned. After webinar 1, we got feedback that the TransferMinder should feature trucks. Some sites only have trucks, no rail cars, so we're building that in. But today, all of the examples will be for rail cars. So let's quickly review the rail car unloading scenario and talk about how we go about improving it. Here we have the basic equipment. We have the rail car unloading station, which this varies by material. For liquids, this would be pumps. For solids, this could be conveyors, which is what we show here. And then destination storage locations, in this case, hoppers or bins. And then we have the transportation in between, in this case for dry product. So today, our examples will all use pellets, but the material could be almost anything. Here we have a basic system that is totally manual with no path confirmation, and we'll build up from here. So now we've added some path confirmation in the form of limit switches so that we know the diverter position. We also show the motors that power the conveyors that transport the product from railcar to hoppers. We've verified the path. In this case, the path is really simple, and in most systems, there will be more devices involved, but you get the general idea. So here we have the diverter in position to carry the railcar contents to the blue hopper. Can we run the conveyors? What don't we know? We don't know what is in the railcar. If we don't know what is in the railcar, then how do we know if the path is correct? The diverter is going to the blue hopper, but should it be? If not, to which hopper should it be directed? We don't know until we know what is in the railcar. Before we get to that, let's look at the unloading station from the top view. This is a top view of the railcar unloading station. The railcar is moved over the unloading station so that the discharge chute or valve is over the unloading collector or pit. Most plants with railcar capability have multiple spurs, and some have multiple unloading stations. They have ways to move the railcars around to the right locations. Here we see a railcar that is in position over the unloading station. When the railcar discharge chute is opened, the material can be carried to the destination hopper by the conveyors. Now, if this was a liquid unloading station, we'd have pumps, pipes, and valves instead of conveyors, pits, and diverters, but the idea of unloading is similar. So back to us trying to find out what is in the railcar. So the railcars arrive at different times and not necessarily in the order that we want them. From the outside, it is impossible to tell what is in each railcar, and even if we could look inside, it may still be impossible to tell the difference between two materials. So the key to knowing what is in each railcar is the bill of lading, or BOL. that is associated with every railcar that ships from a supplier. The supplier will put information into the BOL such as the product code, product name, vehicle ID, and so on. And these are often sent by email. The delivery of the BOLs and the delivery of the vehicles, whether they be a truck or rail car, are not in sync. Vehicles can come at different times and dates, and so can the BOLs. They don't come together. The rail cars don't have BOLs stapled to the side, unfortunately. So the key is to match the BOL to the vehicle. This match has to be certain, or we could be unloading the wrong product. Remember that the product may look similar, but will not be a match. In webinar 1, we talked about how every rail car in the USA has an RFID tag attached. There are two, one on each side, at the right as you look at the rail car. The RFIDs have a unique vehicle ID for every car. They are kind of like license plates on automobiles, but they are RFID that can be read with a scanner. Usually, the same vehicle ID is stenciled onto the sides of the rail car, but these are sometimes obscured by graffiti. The railcar RFID tags are pretty rugged. One is shown here on a pad of paper so you can get the idea of the dimensions. As we talked about in webinar 1, the railcar RFID tags are a little different than most other RFID tags. They have a special protocol, and so not every RFID scanner can read them. The scanner that we are using in the examples today is one of the ones that can read them. It's got a barcode scanner with a laser for the QR codes, and the module in the front is for the railcar RFID tags. It's really easy to switch between barcode and RFID modes. You just press the button on the right side for barcode and you'll hear one beep, or the button on the left side for RFID and you'll hear two beeps. So it's easy to tell the difference between the two. There are other scanners out there. This is just an example. Remember also from previous webinars that TransferMinder does not care which scanner you use. It only has a few requirements of the scanner. The scanner has 4 features we can focus on, which are whether it has Wi-Fi, that it can read barcodes such as the QR codes, that it can read RFID tags, including railcar RFID tags, and that it has a web browser. With these 4 things, we can accomplish what we need to. TransferMinder is a web app that is served up from the server, so using it means just pointing the web browser to the server like you would for any website. QR codes are one of many forms of 2D barcodes. These are commonly used and can be printed on paper and other materials. We mentioned in webinar 1 that we often engrave these on Durablack. This is an aluminum material that is pretty tough. This guy right here is made out of the Durablack. Durablack is the same material is used for the nameplates on industrial motors, for example. So if we put QR codes on the bill of lading, then we have human-readable text and scanner-readable information. The QR code would be added by the supplier. On this example, we have encoded 4 pieces of data into the QR code. 1 is the bill of lading number, 2 is the product code, 3 is the vehicle ID, and 4 is the lot. We could encode additional data if needed, but these are the basics. The format of the encoding is important. If your supplier is already putting QR codes or other forms of barcodes on your BOLs, we can adapt that format, or we can specify the format. Often the BOL shows up first at the site before the railcar, so that we can scan in the barcode to receive it. In this example we created, we encoded the product code, the BOL number, the vehicle ID, and the lot. So by scanning the QR code, we have this information in the system. We'll go through some actual examples in a minute. In the first webinars, we got questions about what the TransferMinder system actually looks like and what parts are involved. The TransferMinder product can be adapted to work with existing systems. Remember, this is just one example. First, there will be a panel. This will be a stainless steel panel so that it can withstand a wet environment. Our prototype is going to be mounted in a panel that is 24 inches by 20 inches. We'll talk about the small enclosure bolted to the side in a minute. Here's a picture of the panel we're using for our prototype. It is a stainless steel enclosure, and you probably have tons of these in your plant already. Here we see the inside of the panel. On the left, we have mounted a charging station for the scanner. This does not have to be there. It's a convenient location for it. The scanner can be charged anywhere. The parts inside are pretty simple. Circuit breakers, DIN rail, wireway, like you see in most industrial control panels. An Ethernet switch. In this case, it has power over Ethernet to accommodate PoE devices and to save wiring. The server. In our prototype, this will be a simple mini computer, but in production models, this will be an industrial hardened computer with redundant hard drives, and then a small PLC. In production models, the server could be located somewhere else, like in a 19-inch rack in the MDF room, for example. Also, there might not actually be a PLC in TransferMinder because a PLC may already exist that controls the unloading area, so TransferMinder could just communicate with that PLC. One nice option would be a touchscreen right on the TransferMinder panel. From there, you could view a web browser and use the app. There might also be safety devices like an e-stop and a blue safety reset button, like shown right here. These are customizations that are optional. Many industrial control panels are wall mount, but certainly a stainless steel pedestal is an option for a freestanding panel. This might be especially nice if the panel has the touchscreen option. Okay, let's talk about connections and more options. First, one or more security cameras could be added to view each unloading station. The live feeds can be viewed right in the TransferMinder web app. The scanners must always have Wi-Fi available since they use a web browser pointed to the server. If Wi-Fi is not present, the scanners can't do much. So we can provide one or more Wi-Fi access points with TransferMinder. TransferMinder can make use of existing Wi-Fi in the unloading area as long as the scanner and the server can talk. As far as outside connections, there are two. 120 volt AC power. This will be 15 amps or less, so it could be powered by a single breaker in a power distribution panel. And then category 6 Ethernet cable that connects TransferMinder to the plant network. This isn't required for smaller facilities without a plant Ethernet network. For small facilities that do not have a plant controls network, TransferMinder can stand on its own and can be interlocked with local VFDs or motor starters that do the unloading. So here we see a basic TransferMinder system. So we have the TransferMinder panel. This one's shown with the optional touchscreen, the Wi-Fi access point, and then one or more scanners. We're showing the plant controls network up here, but if you don't have one, that is okay. It's not required. Okay, we also show a laptop with the TransferMinder web app open, and you can supply the laptop. Since TransferMinder is a web app, you can use any device with a modern browser that is on the Wi-Fi. This could include desktops, laptops, tablets, and phones. Remember that these devices may be able to read barcodes, but only railcar compatible RFID scanners can read the railcar tags. TransferMinder has or will have lots of reporting and history capability, so having these additional devices using the app will provide good visibility, tracking, and reporting. There are other options available too. We can supply additional HMI stations. So we have an additional HMI station here, which can access the TransferMinder web app and also control other equipment in your factory. These options would be worth discussing. We can review what you have in your factory now and how to add options to reach your goals. Many plants have PLCs that already control equipment, as you see here. As we mentioned a few minutes ago, the TransferMinder PLC could be left out and the TransferMinder PLC coding could be added to an existing PLC. Or the TransferMinder PLC could simply communicate with the existing PLC and tell them when it is okay to proceed with the unloading. Here we see such a scenario. The existing PLC controls the unloading equipment like motors and diverters and sees the limit switches to verify the diverter position. We could add a simple permissive to that PLC to the effect of TransferMinder says it is now okay to run the conveyors between unload station 23 and storage hopper 5. For those interested in the data flow details, let's quickly talk about just one example. Remember that this can vary based on your existing equipment. Let's say that the TransferMinder PLC talks to an existing PLC and gives a permissive that is now okay to run the equipment from a certain unload station to a certain destination. This is a very simplified data flow diagram. We want to keep it simple to get the idea across. So we've shown the most basic parts in columns. Okay. Over on the left, we see the scanner with the web app. Then we see the TransferMinder server right here. This talks to both the scanner and the PLC. Then we see the TransferMinder PLC. And like we just mentioned, there may be additional PLCs, but we've just simplified the situation for this example. So the basic communication steps are step 1 here, the operator scans and or selects unload station 1 to go to the storage destination 5. Remember that TransferMinder won't let the operator select a destination that doesn't match the contents of the railcar. For example, if the railcar contains red pellets, only destinations set up for red pellets are available to choose from, or destinations that have no product assigned and are available for any product. So already we know that storage destination 5 is a valid place to send the contents of the railcar at unload station number 1. And then step 2, the server sends the source, unload station 1, and the destination, storage hopper 5, to the PLC. This is telling the PLC to prepare the path. Step 3, the PLC then commands the diverter to go to the correct position. The PLC confirms. In step 4, the PLC confirms the actual position of the diverter by looking at the limit switches. And then in step 5, the PLC tells the TransferMinder server that the path is okay between unload station 1 and storage destination 5. Step 6, the server tells the operator via the web app that the path is verified so unloading can proceed. What is not shown here is how the operator turns on the unloading equipment like conveyors. That is probably not in the TransferMinder web app. it is probably using physical start-stop push buttons or maybe an existing plant HMI. So what has happened here is that you cannot send the contents of the rail car to the wrong place. So we've used some model railroading gear to show a highly realistic example of what the process will look like. Here we see the factory with a rail spur and one unloading station. Just use your imagination. The red paper is the unloading station. And now we see that the rail car with the red pellets being moved into position over the unloading station. And you can see these giant pellets that maybe you made a bracelet out of before. So now the operator would scan the rail car that is at the unloading station. Since we don't have a miniature scanner to go with our miniature rail car, the scanner looks giant. But here we scan the rail car with the scanner. Maybe we could have multiple rail cars to unload. So here we could move the next rail car into position. This is the one with the orange pellets. Once the rail car with the orange pellets is in position, we could then scan that rail car. After we've unloaded the red pellets and the orange pellets, we can now move on to the green pellets. We will now go through the steps to unload a rail car. First, we want to talk about the BOL, or bill of lading. We would receive the BOL and we would scan it into the system. Now, the bill of lading can often be received well before the rail car arrives at the site. So we scan it into the system and we see the product that it is specified in this BOL as green pellets 903. The vehicle ID, the lot number, and so on. The actions that we have available is just BOL receive. So we can receive the BOL into the system. So now it says BOL is received. We can now scan the rail car once the rail car arrives at the site. And we can see the material specified as being in the rail car. It's green pellets 903. The BOL that we've matched it with here. The on-site status shows no because we haven't yet taken any action once we've scanned the rail car. So our actions that are available are simply arrived. So we'll tell the system the rail car has arrived. Now we have a status column that tells us the rail car is on site. Yes. It's online. Yes. The level is full since it has just arrived. And then some other actions that have not yet been performed that are in yellow. Down here we see some actions for the rail car. Offline. We can set the rail car offline, which means just don't use this rail car. We can change the level to empty or partial. We can also do an inspection request, which is what we're going to do now. So we're going to do an inspection request. And typically, the person that does the inspection request and the person that does the inspection are going to be different people. Once the inspection has been performed, we can select a result, either pass or fail. In this case, we're going to choose pass and click on inspection complete. Now we can see inspection completed. Here it says pass and it's in green. So this changes our actions that we have here. We still have offline, empty, and partial. We can scan an unload station now. So we scan an unload station that we have the rail car at and click at unload station to indicate that it's at that unload station. So now at unload station shows station 23. So the rail car is at station 23. So we still have some of our same actions up here. We can tell it it's not at an unload station if we decided to move it again. But most likely we're going to select the destination for this rail car. Now you see we only have two selections here, hopper 3 and hopper 6. We can have 20 hoppers. But one of the beauties of this system is it's only going to give us the hoppers that match with the material that we have in this rail car, which is green pellets 903. So the destination is either going to have green pellets 903 in it or is going to be empty. So we can choose either one of those hoppers that it's specified. So we're already preventing ourselves from making mistakes. So we can select hopper 3 and set destination. So now we see the destination selected is hopper 3. The destination material is green pellets 903, which matches the material that we have in our rail car. So now our actions have changed a little bit. We still have offline, empty, and partial. We have not at unload station, and then we have validation request. So we're going to do a validation request. And here we see path status OK from PLC. The path is OK. So the PLC has verified that the path is OK to our destination. The next thing that we can do is a validation of that path. So if we have the supervisor that wants to validate the path, once the PLC has verified that the path is OK, we can do this. So we can select pass or fail. We'll select pass and validation complete, that they've done that validation check. And now the unload validation completed shows as pass. Then we can actually start the unload by clicking on Unload Start. So now we're in the process of unloading. Notice that the level has switched from being full to partial, and the color has changed since we have started unloading. If we're finished unloading or we want to stop the unload for any reason, we can click on Unload Stop. Now, one thing I want to point out here, we have a timer up here, and you notice it's counting down. What we don't want to do is scan the rail car and then forget about it, walk away, have lunch, and then come back and remember, an hour or two later that we want to do something with that rail car. We want to make it so that the operator would have to rescan the rail car in order to select an action for that rail car. So we're going to let it time out here. Notice it goes to yellow with 10 seconds left, now red with 5 seconds left. It's going to time out and it's going to take us back to the scan page. So now we're going to scan the rail car again. That'll take us back to this vehicle actions page. So now we're ready to stop our unload, either because we've finished or because we want to stop for some reason. So it shows the unload status as stopped. At that point, we can decide we can either restart the unload here. We can say that the unload is completed. So if we want to say the unload is completed, at that point, it's going to prompt us for the unload amount. So if we unloaded 75,000 pounds, 0.5, and then selected the units as pounds in this case, we can enter the unloaded amount. And now the unloaded amount added shows as 75,000.5 pounds. At that point, we can select not at the unload station if we've moved it away from the unload station since we're finished unloading. The two options that we have now, if we were to move it to another unload station, for example, if we still had material to unload, we could do that. More likely, we would indicate that the rail car has departed the site, so we would click on Depart. Now we go back to the scan page and it says that the rail car has departed. Now if we try to scan that BOL, it gives us an error and says this BOL is retired, since we know that BOLs are for use one time. The rail car may continue to show up at the site, but it would need a new BOL each time it arrives at the site in order for us to use that rail car, to unload that rail car. So if we scanned the rail car, it's going to tell us the BOL has not yet been received, since we've already used the one-time BOL previously. We would have to enter or scan in a new BOL for this instance of this rail car showing up at our site. So we're about halfway through the process. We've selected the unload station, station 23, and we're ready to select the destination here. Okay, but let's look at the PLC portion of this. So if we select our destination here, it's going to set the destination here in the PLC. Once we've set that destination, the PLC is then going to move diverters and valves into position to validate the path from that unload station we've selected and the destination that we've selected. Then down here we have a simple rung to run the conveyors from the unload station to the destination. So we have a start push button, a stop push button, and the run conveyors output, which is sealing in around the start push button here. The only thing that we've added is this path OK, where the PLC has validated the path from the unload station to the destination. So because we've added this here, we cannot turn on the conveyor until we have that path OK bit. So we go ahead and select our destination as hopper 3. And we see it change here. And now the PLC is moving valves and diverters to make that path. So once that has occurred, this path OK bit is going to turn on. So now we have the supervisor OK request. So we can request that the supervisor validate the path. Once the supervisor has validated the path, we see that the path is OK here from the PLC. We select the result of the inspection from the supervisor. In this case, we're going to select path and supervisor approve. The unload validation completed is pass. So at this point, we can start the unload. Once we click on start the unload, it'll actually start the conveyor running because we have the path OK bit on in the PLC. We can easily manage both materials and storage. So in video 1, materials would be like product code, description, and what storage locations they're assigned to. There could also be a long list of materials, but you only have a few that are assigned to storage locations. Here we can see that Blue Pellets 501 is assigned to storage hoppers 1 and 4. Video 2, we see storage locations and what materials are assigned to each one. Each storage location can be marked active or inactive, and only the active storage locations will be available for unloading from trucks and rail cars, regardless of what material assignment they have. And hoppers 5 and 6 have no product assigned. Only hopper 6 is marked active, which means only hopper 6 will show up as an available destination when you start an unload. So we mentioned before that every action is recorded in history and who did what. We've looked at BOL history before, so here are 3 other examples. Vehicle history. This shows all actions to every vehicle, even the ones that are no longer at the site. We can filter the history on any field, enter a vehicle ID, or any other search. Here we search on scan to see all vehicle scans, and then write to see all writes to the PLC. You can see how this would be very useful to see what happened at a later time. In video 2, the action history, this is a way to see all actions in chronological order, BOL and vehicle activity. We can expand it to see more detail on many records. And again, it's filterable. And then the third video, this shows scan history. This is very useful for specifically looking at each and every scanner activity. We'll also be adding reporting as well, so you can export these histories. TransferMinder has application configuration features too. So in the first video on the left, we see at the top of the screen, we can see that we're logged in as Walter Casado level 9. And level 9 can see the app config values, but cannot change them. We can see the config values with comments, but we cannot change them. We can see server heartbeat config and PLC heartbeat config. At the bottom, we can see the amount of time that we have on the vehicle action page before we're automatically sent back to the scan page. This is so that you cannot scan a vehicle and then walk away and select an action for it from afar. You have only a certain amount of time to select an action before you have to go scan the vehicle again. Okay, and then video 2. Here we see we can set the interval the web app uses to make sure that the server is still there. Remember that the web app can't do much of anything without the web server. If we turn off the server check interval by setting it to 0, then the server OK indication disappears from the nav bar at the top. We can also set the interval at which the web app verifies communications with the PLC. If we turn off the PLC check interval by setting it to 0, then the PLC OK indication disappears from the nav bar at the top. There are other admin pages too. Here we see the setup of the unload stations in this example system. In this example system, and when we select the unload stations, we see that we have stations 23 and 24 configured, but these could be set up as anything. Also, we can have stations that are marked active or inactive so that they can be excluded from unloading operations. Let's talk about PLC communications. So TransferMinder talks directly to the PLC. We have 2 sets of information, PLC definition and PLC tags. In video 1, the PLC definition defines the PLC itself with a name, IP address, slot, and other parameters that define the communication. Note that the name is chosen by you and is not actually involved in the communication. We can ping the PLC right from this page. This verifies that the TransferMinder web server can see the PLC. The PLC tags are defined in the section below. These include the PLC name, the tag name, and a description of the tag. Here we can see the PLC heartbeat tag, which is used to make sure that the PLC is online and the program is running. Clicking the Read from PLC button gets the value from the PLC, and green is success. We can keep clicking the Read from PLC button to keep reading the value. The heartbeat is updated every second, so we can see that we are getting it in a timely manner. And then video 2, the PLC tags can be configured as needed. In our prototype demo system, we've configured some tags of different types, including some array tags. We can also write values to the PLC tags from here for testing. The TransferMinder web app can be viewed from the scanner, from a phone, or from a desktop, so the pages are responsive to the width of the browser. Here we see the storyboards in the help section, and they are automatically rearranging as the browser width is changed. Here's one more look at that BOL history now that we've received a few BOLs into the system. So we go to History, BOL, and we can see the list of BOLs that we have scanned in history. You can enter a filtered value there and apply it to look at a specific BOL. A note about security: each user has a username, password, and security level. Here we are prompted to log in on the left panel. Then in the middle panel, we enter a username and password. And then on the right, we see that we are successfully logged in as Walter at level 9 out of 10 levels. Without logging in, we can't do anything. On the right, we now see the green scan button up in the right-hand corner here, since we are actually logged in. What's next? We're building the demonstration TransferMinder panel. Development continues. We're interested in your future requests. We're interested in discussing what you need at your facility. Please contact us for planning and quotes. And we want to say thank you. Please contact us for more information about validation systems. So now we're going to go ahead and take some questions. So Luis Casado is going to come on the mic.
Thanks, Walter. We've got several questions queued up and more coming in. One question we had after webinar 1 was about trucks, and you mentioned that earlier in the program. What if we have all trucks and no rail cars? Well, we can accommodate that. As we said before in webinar 1, rail cars have RFID tags bolted to them, so they're inseparable. Trucks would have a BOL, a bill of lading, that comes with the driver, so it's not physically attached to the truck, and there could be some confusion, but if you manage the paperwork well, the system can definitely track the trucks, the BOLs, track the receiving and do the reporting. We're building that in. It's not quite ready to show, but we could do trucks and or rail cars in the same system interchangeably. The next question is, what if my plant has no network, no PLC, and no Wi-Fi? Well, that's okay. We could accommodate that. We can supply the Wi-Fi access points. We can create kind of a mini network, a standalone network. Pardon me. As for the PLC, we can supply a small one that could be interacting with the hardwired push buttons and things that you mentioned earlier. If you just have hardwired stations with push buttons and things to control the conveyors, we can put a permissive in there with the PLC so that the start button won't actually operate until the path between the two is verified. That might also mean you've got to add some sensors to make sure the diverters, gates, and valves are in the right position, but that shouldn't be a big deal either. Well, on the other hand, what if our plant has a huge controls network? We already have Wi-Fi. We have lots of PLCs. Well, that's okay too, because we can add the TransferMinder logic to the PLC that you have, and the TransferMinder server can talk to that PLC. Well, next question, what if our plant already has servers? Well, we're looking at that possibility, and the plan is to make TransferMinder an installable product with database included so that it could be installed on any server. Wouldn't have to be one that we supplied, but that's just a nice way to receive the package. So two more questions in this list. When will TransferMinder be ready for release? Well, that depends on new feature requests, the demand, and what's most important to our customers. For example, is the all-inclusive version or the standalone version more important to customers? The next step is we'll have our demo system built up, and we can demonstrate the whole thing with push buttons, pilot lights, and everything live action. We'd love to hear more from customers about options and features that they would like, and we'll be talking to customers with rail spurs and truck receiving stations, truck unloading stations as well. The next question that we get is, how do we reach Kate's to talk more? Well, our website, if you go to the Kate's website and select products, at the bottom you'll see TransferMinder, and there's links to the other previous webinars and this one. And you can also see emails and phone numbers, contact information to reach out to us. Chris is our sales manager, and all the emails from that website go straight to him, so they do go to a real person. There's a phone number to call as well, so we'd love to hear from you. So thank you so much for joining the webinar today. Stay tuned for more updates on TransferMinder.